everyone, welcome to another episode of Block Talk. Today we're going to talk to you guys a bit about Hyperledger Fabric. My name is Brenda, I'm a PM on the blockchain team.
And I'm Kale, I'm an engineer on the blockchain team. And we're going to talk, as Brenda said today, about Hyperledger Fabric and specifically the latest version, which is 1.3, the latest stable version. We're going to talk a little bit about the core infrastructure, what makes up Hyperledger Fabric. It's evolving quite rapidly. There's a lot of interest from enterprise specifically for this type of technology. And then we'll talk a little bit about the Azure side and how this applies.
Great. So what exactly is Hyperledger Fabric and why do enterprises like it so much?
So Hyperledger Fabric, you can think of it when we talk about other chains, like for instance, let's draw something to Ethereum. So Ethereum is one of these chains where it works in both public side, so there's a public cryptocurrency and a network that's running there, and then there's also the side that's private, where companies are saying we want to build a permission network that allows only certain members to come into that network and function. Hyperledger is kind of like the second part of that, right? So it was built ground up to be a private blockchain.
Got it.
It's not exposed to the public mainnet or any of that kind of stuff. It doesn't have any of that stuff that goes around with it.
I see. Okay, thanks. And there's a lot going on in this diagram.
Yeah.
Do you want to explain kind of how everything ties together?
Sure. So this is really kind of a high-level look at like what is the architecture for Hyperledger Fabric networks that people would be putting together. Now, if you take a look at this slide, as you said, it's a little bit of an eye chart, so I'll kind of walk through this. And what we want to do in this session is just kind of walk through what are the core functions for all the different node types and things that you're seeing on the screen, so that as we get into deeper sessions, we'll already have that base knowledge and we can start building things like chain code and some of the higher level application functions on top. So in this diagram, if you take a look, you'll see basically we have a lot of different things. So if we start at the left side, we'll see these CAs. So the identity system that's applied inside of Hyperledger Fabric is much different from something like, again, I'll draw the corollary to Ethereum. In Ethereum, we basically have these key pairs that are being generated for us through commands that we can issue. They can be generated offline, and they have a public address associated with them. In Hyperledger, they're using things like certificate authorities to do those key pairs. So essentially, you have to have a CA, and from that CA, you'll create intermediate CAs, and then from those, you'll generate keys, and those keys will be tied to identities.
Got it. So does every individual organization have to have their own CA, or is it shared, or is it one per member?
It's not a hard requirement that you could definitely stand up one and just have one CA. But in that case, basically, it's how much trust do you have with those participants.
Got it.
So if we are business partners and we're very closely connected and it's just us doing this thing, maybe with another partner, potentially we could share infrastructure in that case. The downside of that, that's like the pro, is that we have less infrastructure. The con is that now we have more trust. So if that single thing gets compromised or messed up, it would mess us all up.
Got it.
So there is a desire I see from these bigger networks that they build for them to bring their own CA. It's interesting when we talk about the Azure piece, we're trying to make it easy for people to use this technology. So we give you the option, like we can spin up the CA for you, or you can bring a CA, a root cert from your CA to us.
Neat.
So these are your certificate authorities. Think of those as like the identity system that's being built here. And then we'll start talking about some of the node types. So basically, in this case, we basically have one participant here who's going to be the network creator. That's what this NC stands for. And then we have these organizations that are tied to it. You can think of organizations, they don't have to necessarily align directly to a participant, but in many cases they do, right? So you could say, hey, I have organization 1 and organization 4 in this case, who's going to be functioning the order. What is the order? You can see this line that's going over here to the order, and this is the same color. So basically, the order is the consensus mechanism.
Got it.
The order is the back end that's going to absorb these transactions. It's going to validate and don't allow things like double spend and different things that would happen there. It's going to make sure transactions are in the right order and people aren't compromising the system.
Okay, so similar question that I had with the CAs. Is this also operated by one participant, or is it shared, or how does that work?
Now, it's an interesting question. So the order in this case, there's two different ways to run the order in current form. One is called solo, which is mainly for developers. So you can think of it almost like an in-memory type messaging system. It's great for speed and getting things working. So for a developer, it works great. But it's not really something you would use in production. In production, and when you see it in the Azure Portal, you'll see a selection for this. You basically are running a Kafka node cluster behind the scenes. So Kafka is a messaging service. You can imagine that these transactions that have been signed by the various participants on the peers are coming into this order to be ordered and put in the right spot.
Got it.
And the Kafka nodes are providing that function. So to answer your question, there typically is a highly available cluster that's built there of Kafka.
I see.
Typically, that's not dispersed in the current form. Some people could argue that that's a centralization point, and it is.
Right.
But there is work that's happening there right now to provide things like Byzantine fault-tolerant systems inside there to remove that dependency and make it a bit more decentralized.
Okay.
But in current form, we use Kafka there for the production setups. And then from there, basically, you'll notice that we also have these peers on the screen here, and we see those in other blockchain technology. Typically, that's where people are interfacing with from dApps or directly into the blockchain itself. You'll also see things like channels here. So let me talk through a little bit about how this works. So basically, we have a channel configuration. Now, the channel configuration, a channel, is basically saying, I'm business A, Brenda's business B. We're going to do some stuff together, and we don't want anybody else to see what we're doing together. So in this case, I could be org 1, she could be org 2. We have a channel configuration. We agree to that configuration together, and then essentially we've built channel 1. Channel 1 can be tagged to any peer. In this case, it's tagged to peer 1. And then we essentially are going to deploy code to peer 1, like our smart contract type applications. In Hyperledger form, it's called chain code. But we would deploy some chain code there, and there's a ledger there that we're actually using. So me and Brenda are now doing transactions, and it's just me and her. They're ordered, so we're basically going to sign the transactions ourselves, and then we'll send them to the order. The order will make sure that everything's valid, the right keys were used, all the right permissions, and everything, policies are applied, everything is correct. And then it gets committed to the blockchain, and you can basically see the history.
Okay.
Now, you can imagine that you can build these networks and then have multiple channels.
Right.
So I could say, in this channel, I'm just working with Brenda, but maybe in another channel, I'm working with somebody else. And maybe Brenda's working with 2 other people on a different channel.
Okay.
So you can see these things kind of sprawl out, and you can create these channel configurations. So you're basically building peer-to-peer systems like that these people can talk to. Much different from something like, again, to like an Ethereum where we say basically broadcast it to everybody.
Right. It's you can select exactly who you want to talk to and what every person in the node sees.
That's correct.
Or in the network.
That's correct. And which applications they have access to, which smart contracts they have access to.
Right.
So you can imagine that there's quite a bit of setup to get something like this running because there's a lot of things on the screen here. And this is, I think, one of the challenges we have with this technology is there's so much infrastructure that we need to put in place and configurations that it becomes very difficult for people to stand these up effectively.
And lots of points of failure as well, I can imagine.
Yeah. So we took a look at this, and about a year ago, roughly, we had published the Hyperledger Fabric. I think it was even in alpha form at that point, up to Azure, and we're basically just announced the arrival of 1.3, which is the upgrade basically, and brings a lot more new features to this. So I want to talk through some of these features on the slide you see here, and then we'll take a peek at the portal and take a look at how you actually can start taking advantage of this stuff. So basically on this screen, if we just focus on one of these boxes, we'll take the left side, for instance. When we stand up a network, if I say, hey, I'm going to stand up my Hyperledger Fabric network, Brenda's going to join into my network. I'll initially create the new network. I'll set up the orders. We have to have orders. We can't run the network without them.
Right.
And then I'll basically, you can see the ordering. I mentioned that we have Kafka and Solo. So depending on whether I pick like a developer type deployment or if I'm picking something that's closer to production type thing, the production one will be using Kafka, the developer one will use Solo.
Okay, and is that a configuration that I can choose when setting it up through Azure?
Yeah. So basically, to be honest, it doesn't even expose that back. So we took even that bar away from people because basically no one's going to run Solo in production.
I see.
Because it's just something that runs in memory. It would that would be a disaster.
Got it.
So if you pick the multi-node deployment, you're actually going to get Kafka by default.
Nice.
Now on the peer side, we mentioned peers are the things that the application's actually going to interface with to do things. You'll notice we have some DB like little symbols underneath here. So the persistence and the things that are happening on those peers can either be stored in 2 different places. One is level DB and the other is couch DB. Now we give this option when you're deploying your network, and the interesting thing is it's not an all or one. So if you come in and say I want to put 3 peers on the network, you could basically have one of them using couch DB persistence and 2 of them using level DB.
Okay.
Sorry, go ahead.
Sorry, and is there a reason why we provide these two different options?
Yeah, it's a great question. So LevelDB was there from the start. Great persistence mechanism. A lot of blockchains use that. But CouchDB was added so that we could provide additional analytics.
Oh, nice.
So, for instance, if you're building an application and you know that you're going to come back in and want to like look at some of the metadata around the transactions and all the normal stuff that we do, CouchDB is a really good thing that has evolved. I think 1.2 with Hyperledger brought it in, but 1.3 continues to evolve it, and it's great for analytics. So just keep that in the back of your mind. If I want to do analytics, CouchDB
is the way to go.
I'll give you the pro and con there too. The reason we don't just like turn on Couch for all the peers then is there's a lot of kind of network traffic and overhead associated.
Right.
So in most cases, you probably don't need that on every node.
I see.
So that you can keep performance things in check.
Right.
I do have the CA in here. So by default, we will spin up a CA for you and an intermediate CA. And that's where the identities will hang off of those keys that are associated with those certificates. You can also bring your own. So if you want to bring your own, you have your own CA infrastructure, you can bring your root cert over here and then essentially start tying the organizations to that.
Quick question, actually.
Sure.
So I'm not an expert on identity and things like that. So what's the difference between the CA and the intermediate CA? Like, why do we need both? Do they serve different purposes, et cetera?
Typically, it's a great question. Typically, the root CA, we'll call it, or the CA, is very protected in a special place that we usually don't use on a day-to-day basis.
Makes sense.
Intermediate CAs is one that's tied directly to that root CA, so he's the one who generated the certs for the intermediate CA. Then the intermediate CA can hand out certificates off of itself. So you can think of if that intermediate CA got compromised, the root's still there.
I see.
So usually keep that one kind of isolated, and then the intermediate CAs are a little bit closer to the front lines.
Makes sense.
Yeah, in case there's any kind of compromise.
Cool.
We also have different options we've been working on with Composer and admin tools to help people use the networks. But those are features that we're lighting up in this as well. The core infrastructure is what you see on the left side. The right side is a bit more. You can add those yourself, by the way. So once you stand up the Hyperledger Fabric, you can essentially add any of the open source tools to it. We're just automating getting those nodes all stood up and getting all those connections made so that you don't have to kind of futz around with those connections.
Nice. So if I wanted to use this in Azure, how would I go find it?
Yeah, it's a great. And one thing before we move to there, I just want to mention the VPN tunnel. So we can do multi-subscription, we call it. But again, it doesn't need to be Azure to Azure. You could spin up and say, hey, I'm creating a new network in Azure. And then essentially you're going to get the outputs, things like what's your network look like, your network configuration. If Brenda comes along and says, hey, I'm using Azure as well, I can provide that information to her. When she stands up, she does a join network. We'll see in the portal here in a second.
Nice.
And she can do the same thing of basically making that VPN tunnel connection so we have a private network, and then basically bootstrapping her peers. Now, in her case, she might not be standing up orders. She could. I put it on the slide just for completeness, but in many cases, as you mentioned before, there'll just be one set of orders. Most of the time, the people joining are just peers.
Got it.
So they would just add their peers into there, whatever persistence level that they wanted. They will have a CA typically. They could share it, as you mentioned earlier. Right. It depends on how much trust they have with the infrastructure.
But the order is generally shared.
That's right. So when you pop into the Azure portal, I'll just walk you through some of the steps here around how you provision it. So you'll basically give a name that's going to be prefixed to all your resources. The scale type. This is where we were talking about before, Brenda, where we said, am I going to use a solo backend or a Kafka?
Right.
If I do a single VM, obviously that's not a production level system. It's basically going to have a bunch of containers on top of it that run the order of the peers, all that stuff.
Okay.
If I do multi-VM, I get more options, right? Because then I'm basically using multiple virtual machines. This is more of a scale-out production scenario. This will turn on Kafka. And then basically, you can pick your storage mechanism on your VMs. You can username and password that you can use to get on those VMs. You have to put in a resource group here. Let me go ahead and create a new one. And then your location where you want to deploy it. Now, here's where you get into some of the network configuration. Try to make this as simple as possible. And we're always open to feedback. So as you guys start using this stuff, we'd love to hear feedback on how we can make these things different, but we're trying to make the easiest path through here for people. So basically, you can spin up a new network if nothing else exists. You can join an existing one. You notice when you join an existing one, you're going to have to pick a member ID. This is like a permission network, and the network join file. So this is something that will be provided to you by the guy who created the network in order for you to join in. You can also see that we have these organizations set up default or advanced. And again, as I mentioned with the CA, this is the CA portion basically. So if you pick default, you see you don't get any options. It'll go spin up CA, a root CA, an intermediate CA, do all that stuff for you. If you say, no, I know what I'm doing, I want to do more, you can change the name of your org, you can upload your root cert, and you give the password associated with that cert. And then at the bottom, you have your VPN tunnel. So again, if you want to enable truly private connections, you could essentially toggle this on. And then you'll have a VPN gateway. When Brenda comes along and says, yes, I'm also using Azure, I want to attach to you, the gateway will allow that communication to happen.
Cool. Is it possible for me to turn it on after the fact?
It is.
Okay.
So these are like basically things just to get you going from the start. If you wanted to kind of mix and match or add things afterwards, you can obviously go in and tweak the components that get deployed, the resources. Now this is, you see we were in a multi-VM form. So when we're in this form, we basically are allowed to say how many order nodes do we want. In this case, we limit it to 4. And you can see there's a little message here about it being a Kafka-based configuration. And there's a link there that can like provide you more info if you're not sure what that stuff means. You can pick the sizes, and then you have the same thing for the peers. Now on the peers, it's a little different, right? So we can still pick how many we want. Let's say we pick 2. You notice the UI changed here, and basically we have node 0 and node 1 state persistence. As I mentioned, we could say, yes, for this one I want CouchDB, but for everything else I want LevelDB. So we can kind of toggle those things. And again, we can pick the size of that. And that's pretty much it. You know, when you go to deploy this thing, this will get you a network stood up, get you running, and then, as I mentioned before, we'll be providing other sessions to kind of talk through, you know, some of the core things you're going to do after this. Once you get the core running, you're going to say, how do I build those channels that we talked about?
Yeah.
How do I put chain code up there? How do I like test this thing?
Yeah. How do I get started?
Yeah. So we have some documentation around this stuff and the architecture that we just went through here. And we're going to be adding to that. So we're going to provide some more walkthroughs, and also we'll have other sessions on those.
Yeah, great. So for all of that information that we just covered in this session, you can view those links in the description section below. And so I want to thank you guys all for joining today. Thanks, Kale, for your time. And feel free to follow us for more updates, including subsequent updates for Hyperledger Fabric, you know, how to upload your chain code, how to get started, how to start developing. So feel free to follow us at MSFT Blockchain on Twitter, and we'll see you in our next episode. Thanks.
Thanks.